Today in this video, we're in the unit of Mathematics of Finance. We are going to be looking at the ideas of compound interest and inflation. You're going to see where that compound interest formula came from back when we were talking about our exponential growth and how we arrived at that. But we're going to apply it to the idea of inflation, and we're going to be looking at future values and present values of loans and investments in situations where we're dealing with compound interest. All right, so let's start off with just this. Compound interest, again, is interest not only on the investment, but also on already earned interest. Okay, well, so this shouldn't be a new concept. Most people understand at least the idea of what it is. So really quick, let's take a look at this. Let's say that you've invested $1,000 at 4% interest compounded quarterly, so 4 times a year, for the first year. So we take a look, the first we start off with is $1,000, of course. Interest is principal times rate times time. There's that fractional period of time. Just for one quarter would be 3 months. We end up with $10 of interest. So by the end of the first quarter, we have $1,010 to start our second quarter. Repeating that process, we get a little bit more. And then we plug it in, we get a little bit more, and so on and so forth. So at the end of the year, we have $40.60 in interest. Our balance then, the principal, is going to be at $1,040.60. Notice that this process had to do with calculating the interest so that we could plug it in over here. We had to plug our interest in there. That's all we were doing right here, was just figuring that part out. In the last video we looked at, we actually discussed the idea of this, that when you're talking about your future value or maturity value, this could be applied to a loan as well. Of course, it's principal plus interest, but the interest, we have to use the formula interest is principal times rate times time. So if we substitute that in and then factor out the principal, we end up with this expression right here. Okay, so then the future value or maturity value, depends upon the context you're talking, is the principal times 1 plus the rate times the time. That becomes handy for us because here's the same exact scenario, but really half the work. We go through and we can skip that middle column of calculating out the interest, and we can just insert it all into right here. And notice we end up with the same exact value. It's just using this formula instead. So obviously this is a little bit more useful of a formula. Makes our lives a little bit easier. But then we can make it even easier still if we employ the idea of a exponent. Exponents are a way of doing, hey, we did this 4 times. We took the what we started out by, the calculation for how much we're adding each quarter, and how many times did we do this. Well, that's what exponents are used for. So I can take all that work from the first slide and I can reduce it down to one simple equation here. There is a little bit of a tweak, something that happened here. You do have to take into account your interest rate then gets divided up by 4 because we compounded 4 times a year, in this case quarterly. And then that's that same 4 here. And then I could extend this even farther and go, hey, what if we did this for several years? Well, then I could put another variable up here, t, for years. And hopefully this looks very familiar to you from our exponential growth unit, because that's exactly what we're talking about. And this is how in banking, whether you're talking about future value for investments or maturity value for loans, this is how they actually go about doing that compounding. They might actually break it down to the day, but it's still, this is the process that's used for doing those calculations. So that, of course, gives us our compound interest formula, and we'll be using this actually differently than what we've done in the past. You're going to see that you've pretty much always been solving for this. Well, we're going to be looking at either case as we go through it. Just a reminder real quick, annually is once, semi-annually is twice, quarterly is 4 times, monthly of course is 12, and daily. We're just going to use 365. I know if this was an astronomy class, we would use 365 and a quarter. But this is not an astronomy class, so we can round it. It's really not going to make that much of a difference when you're talking about compounding that many times in a day. Here's something that we're going to do different though. When you see this formula in an exponential growth unit, we never use this vocabulary. But because we're doing the mathematics of finance, and finance talks about future values and present values, we're going to use those, and you're going to see these a lot. And I'm going to use some notations here, some FV for future value, PV for present value. This is what you start with, the present value. This is what you end with in the future value. Sometimes we're solving for the future value. I've got this much money, I want to invest it, what am I going to have? Other times it's I want to end up with a certain amount of money, how much money do I need to start with? So sometimes you're solving for one, sometimes you're solving for the other when it comes to finance. We'll be doing some of both. And so it really goes either direction. It's not just solving just for your future value. It could be either situation. So let's take a look at this. How much money needs to be invested today? That's present. How much money needs to be invested today in order to have a specific amount in the future? So here would be a scenario. How much money should we invest in an account that earns 7% interest, compounded monthly, in order to end up with or have $50,000, that's a future value, in 10 years? Okay, so in this situation here, we're trying to solve for the present value. Notice I switched from P and A to just present value, future value. It kind of helps me keep track of what we're doing here. I know the future value. I want to know what's the present value. How big of a chunk of money would I have to put in order to end up with this amount in 10 years? Well, a little algebra then. If we're solving for the future value, I had to divide both sides by this big monster expression here. I'm not going to write it all in, but I would divide both sides by that. And that's how I ended up with this right here. So now that's what I'm actually going to be doing. I'll take the future value divided by this expression, and that'll give me my present value. So I just plug the stuff in. Don't forget, you always insert the interest rate as a decimal, not as a percent. So 0.07. Of course, monthly is going to be 12 here. The 120 is 12 times 10 years because it's got to be the number of times a year times how many years. Because how many times are we compounding it? That's what this is. How many times are we multiplying by this guy? 120 times. We go through, we divide 50,000 by that, and we would need to start out with approximately this right here, $24,879.81. And most people will probably just say, hey, just throw in 25,000. We would round up a little bit probably, but this would be the exact amount right there for the present value, what to start with. I'd like you guys to pause and try this on your own. They want to have 5 years in the future, a value of an account of $10,000 at 4% interest. What's the amount of money that they need to plug in right now? What's the present value if it's compounded quarterly? So pause this, give it a try. All right, so again, what you would have needed to have done, we were solving for the present value. So you would have had to divide by this big expression right here. I'm not going to write it all in, but you would have divided by all of that into the $10,000, and you should have ended up with $8,195.45. So we're going to kind of switch a little bit. We're going to be talking about inflation because inflation is connected to the idea of compounding. Inflation, I'm just going to read the definition here and then I'm going to try to explain what it means, is an economic condition during which there are increases in the cost of goods and services. So, for example, let's say that a gallon of milk used to cost $1.50 and now it costs $2.75. Okay, it's usually due because of somewhat, at least a piece of that increase is due because of what's called inflation. What inflation really is, as the government pumps more money into our economy, and if you just Listen to your local news. This is happening all the time. The value of each dollar goes down, which means it takes more dollars to buy things. Let me explain that a little bit. Why would it go down? It has to do with, in economics, what's called supply and demand. For example, let's say that I had 10 very hungry teenage boys. Let's say they're like 17 years old. They're hungry, and I have one candy bar. And let's assume that all these boys have some money on them. And I put up that candy bar for an auction. I literally have done this in my classroom before. You can get $5, $6, $7 for one candy bar because there's just not that many of them. But then let's say I have those 10 hungry people and I pull out 10 candy bars. Well, now I have more of them. That makes them not worthless as in of no value, but worth less money because everybody's going to get one. So now if I hold an auction, well, they're not dumb. They're going to not bid as much because there's a bunch of them to be had. That's the idea of when you have a larger supply, the price point goes down. Well, the same is true with dollars. Dollars are wanted, okay? But if you have more of them and they're easier to get, then the value of them goes down. They become worth less. Not as in zero value, but the amount that each one of them is worth becomes less and less. So as a government, no matter what government you're talking about, if you ever hear of a government situation or a country situation where they have crazy inflation, if you pay attention, they're also printing money like crazy. In some cases, it's physical cash. In other cases, it's they're loaning out money digitally through, from the Federal Reserve Bank to the local banks. Anytime a loan occurs, you've literally created money. And so by having debt causes inflation. Okay, so I'm going to stop now because you could go on for a couple hours on all of that, and I don't want to completely go down that rabbit trail. But that's the idea of inflation. The money that's out there is worth less and less, which makes things get more and more. Typically, when you talk about inflation, though, we don't need the entire compound interest formula. We can ignore the ends, the quarterly part or how many times a year, because usually when you talk about inflation, you're talking about annual levels of inflation. Okay, so I can simplify, and this is the formula we're going to use when we talk about inflation. So take, for example, that your salary today is $35,000 and you want to know what it would be equivalent salary in 20 years. In other words, if you have the same purchasing power, obviously it's going to take more dollars because inflation is going to cause those dollars value to go down. Well, many more dollars do I need to have? That's called purchasing power. I can buy the same stuff. Okay, so for whatever you can buy for $35,000 this year, in 20 years, how much money would it take to be able to buy the exact same amount of stuff? So purchasing power. Well, let's just, for assumption's sake, let's just pick a number. Let's say 6% is the inflation rate. It's pretty straightforward. Don't forget, though, this is going to be a decimal. So this would be my present value, future value. Present value is $35,000. I want to know what my future value is over a period of 20 years. It's pretty straightforward. Run it through your calculator. It'll be 1.06 raised to the 20th power times 35,000. And it would take, at 6% of an inflation rate in 20 years, you would have to be earning over $112,000 in a year to be able to buy the same amount of stuff. Okay, purchasing power. Inflation really, really does affect our lives way more than people realize. And so it is something to put some thought into, and I'm going to talk more about that before I'm done here today. Okay, well, let's take a look at something that's a little bit more specific, something that I know something about. I started my teaching career back in 1998, and my first contract, so my first year teaching contract, was for about $25,000. I rounded a little bit there. In 2020, the starting salary of a teacher was about $37,000. Over those, actually, this is 22. Over those 22 years, the average inflation rate, I looked this up, was on average 3.22%. So a question might be, so a new teacher coming in 2020, do they have the same purchasing power as I did back when I started my teaching career? Are the teachers' salaries keeping up with inflation? That's really the question I'm looking at here. Well, let's calculate it out. What I'm going to do is I'm going to start off with this as my present value back here, and I'm going to see what the future value should be in 2020. And then I'm going to compare that number to this number right here. Obviously, if this is more, or let's just say equal. If it's equal, then yes, it's keeping up. If it's more, then it's more than keeping up. If it's less, then it's not keeping up. So let's just compare those here. So here's my calculation right here. Again, the amount I started out with, the present value back in 1998, times 1.0322, so 1 plus the inflation rate, that's the average inflation rate over those 22 years, ended up being 50,204. So you compare these two numbers. Obviously, this is much lower. So you'd say, no, teachers' salaries are not even close to keeping up with inflation. Which, guys, this is actually kind of a useful thing to think about as you look at careers. So let's take a look at another one. Let's take a look at nurses. And now nurses, I didn't find all the information all the way up to 2020, where we are now. So I'm going off some numbers. I've got some 1992 numbers, and I've got some 2015 numbers, which was 23 years difference. In those years, because it wasn't the same years as the teacher ones I was looking at, those years the average inflation rate was 2.31% between 1992 and 2015. So this is a few years old now, but it'll give you the idea. So I'm going to do the same thing. I'm going to start out with this being the present value back in 1992, and I'm going to run that through for 23 years at 2.31%, and when I'm done, I will compare it to this number right here. Okay, so here we go. 37,750 times 1.0231 raised to the 23rd power gives 63,831. So now we compare these two numbers. And what you can obviously see here is that if they had just kept up with inflation, this is where they would have been, but that's not the national average, at least in 2015. This was the national average for a registered nurse, which means they're above inflation. So much of this is still about economics. What's happened in those years, the baby boomers are retiring, they're getting older, they're going to nursing homes, they're getting sick, they're going to hospitals, and the demand for registered nurses has gotten huge. Supply and demand. When the demand goes up, the price goes up. So nurses can demand more salary. They can negotiate for higher salaries because their services are so much in demand. So they've more than kept up with inflation. This is actually a great exercise. If you're a high school senior and you're contemplating different possible career paths, do a little research and take a look. Is your career path the thing you're interested in? Is it in demand? Is it the kind of thing that will keep up with inflation or not keep up with inflation? Not that you need to necessarily make your decisions based off of that, but at least you're going into your career informed on what to expect. I knew going into teaching that I was not going to get rich from being a teacher. I didn't expect it, and I still don't. But I do enjoy my career, and I've enjoyed my life. Nurses, they're in demand. Their salaries are going to go higher, and again, they enjoy their life too. But it's just something to consider with whatever the career path that you're. Okay, one more thing here, something to think about. Many of you should know what a passport savings account is. And again, I mentioned this in a different video. They used to look like this years ago, and people would write in or stamp in like the amounts that you had. So they actually looked like a passport book. So that's why they called them that. But just the idea of that plain old savings account, you walk into a bank, you got some money, you say, I want to open a savings account, you put it in. That's called a passport savings account. And I want you to look at, Here are the historic rates for passbook savings accounts. You'll notice they've actually dropped down. Now this only goes up to about 2018. This is the one I found, but trust me, they've actually just gone down. They're less than that now. Now they're below 0.05. And notice this. This isn't 5%. This is 0.05%. Okay, it's not like I move it two more decimal places. As a decimal, it would be 0.0005. These are tiny percent rates. You're getting nothing for your money, really, when you put it in a savings account, just a regular Passport savings account. I want you to compare this with, I'm going to go to a website here, with inflation rates over those years. We've got some historic inflation rates. Remember, just real quick here, let's say 2016, you're making, I don't know, 0.06%. Okay, so let's go back to that historic inflation rates here. If you take a look at here, here's 2016 right here. 2016, the inflation rate was 1.3%. Remember that Passport? 0.05%. I mean, inflation was almost 3 times as much as what the interest was in that book. And I don't know, there's some low years here. Get this out of the way. If you look at 2015, inflation was only 0.1%. In fact, back in 2009, because of the recession, inflation actually went negative that year, which is kind of an interesting idea. But on average, you can see, most of these inflation rates, they're, 1 point something, 2 point something over the years. Obviously, it changes every year, and this is the average for the year. It technically is changing constantly, but for the year, we're looking at the averages here. I want you to think about this then. If these are all, 1 point something or 2 point something, and you put your money into a savings account, think about the purchasing power. You put your money in. Think about $100. You put $100 in. You're going to get, next to nothing. It's in a year's amount of time. But a year later, you have less purchasing power because of inflation. You are literally losing money over time when you put your money into a savings account, which I know is backwards from what people try to teach you and what people tell you. But if you look at the mathematics, you're losing purchasing power. You're not losing dollars. You will gain dollars eventually, but you're losing purchasing power when you compare it to what's happening with inflation. As you get older and now look at investing, you need to make sure that whatever investment you're looking at least beats out inflation. Because if it doesn't beat out inflation, your purchasing power is going down. You are, in a sense, losing money. Again, you're not actually losing dollars, but you're losing money because the value of the dollars has gone down. Just something to think about. All right, if you're in my class, there is an assignment in Schoology. Have a good day.